Thank you for having me. My name is Cheolhwan. I'm a PhD student at Yale. Today, I'm going to present my job market paper, The Spatial Consequences of Regulating Local Air Pollution from Industry. So in these projects, I'm going to study the effect of a time-based and place-based environmental regulation, the geographic distribution of emissions and output. This is a standard disclaimer since I'm using Korean census data. And this project is motivated by the fact that local air pollution remains a severe problem across countries. For example, when you look into particulate matter 2.5 in the air, it's around 5 times of the WHO guideline in 2023, and it's much more severe in developing countries and world factory countries such as China and Korea. Many advanced policies such as cap-and-trade system have been introduced to address this kind of problem. However, due to limited regulatory capacities, these policies are either size-based and sometimes place-based, especially for local air pollution, whose effects is concentrated in time and space. As a result, regulated plants can either abate emissions with clean technology by using electricity or gas instead of coal or oil, or they can also use filters or scrubbers. In either case, they can leak emissions within and across sectors and regions that are not targeted by this policy. The magnitudes of these channels matter for policy effectiveness and economic outcomes. There are some recent studies that examine the welfare effects of these policies, but they are subject to some data and framework constraints. For example, it was kind of hard to see a counterfactual control group in some sense, and as a result, it was kind of hard to see the spillovers or leakages in these studies. So what I do in this paper is to use new data covering the universe of manufacturing and power plants in South Korea and provide some unifying evidence and framework, asking the following research questions. How much emissions reduction can be attributed to abatement and leakage channels? And what are their distributional consequences within and across sectors and regions? Finally, the targeted industrial environmental regulations enhance welfare. I will give you some simple schematics that kind of summarize the framework of this project. So first, polluted and populated districts are regulated when there are 2 districts. And there are large and small polluters in manufacturing and power generation. Some of the manufacturing plants are under the same form of ownership. In these regulated districts, only large polluters within regulated districts are regulated. Here, in this case, in this specific Korean context, it will be manufacturing and power plants because they account for around 82% of emissions in this district. Once they get regulated, they can either abate emissions with clean technology or they can leak emissions to other unregulated plants because they basically produce tradable goods. It means that they can produce in one place but sell to other places. So there are many leakage channels. For example, if this is within firm, there will be some specific LST substitution data that control this within firm leakage. Also, it can be across firms with the sigma, which is again the LST substitution between firms. Lastly, there can be some leakage to fossil fuel power plants because these manufacturing plants can start using more electricity and less fossil fuel, but they will somehow leak emissions to fossil fuel plants that are either regulated or unregulated. So what I do in this paper is basically to study this targeted environmental regulation and its effect on the distribution of emissions and output. And just to preview the result, I go through these 2 steps. First, I use difference in differences and estimate relative policy effects. What I mean by relative will be clear in the last bullet point. The specific policy context is basically a South Korea's 2020 cap-and-trade system for local air pollution on NOx, SOx, and TSP. Emission reduction was there, but they were mostly driven by manufacturing, not by power plants. It was around 50% at the district times industrial level in manufacturing. There are also all these abatement and leakage channels. They started using more emission control devices such as filters and scrubbers. They also started using more electricity. However, in addition to that, I also found some evidence of within-firm spillovers and some leakage to power plants as they start using more electricity, and also to nearby districts. However, this leakage creates some biases in these reduced from estimates because there are basically spillovers to this control group which are not regulated by this policy. To address this problem, I provide a structural approach to interpret this reduced from measures with my structural model and also to conduct some welfare analysis. So I build a spatial model of manufacturing and power plants. And through quantification, I find that leakage overestimate manufacturing emissions reduction in this reduced estimates by a quarter. And also I did some counterfactual welfare analysis, finding that it was welfare improving in the sense that it decreased pollution damages by 5%, despite some 1% loss in consumption and production. And I also tried to see other counterfactual policy experiments and compare the results. And it turned out this policy outperforms spatially uniform alternative despite spatially uneven effects through this leakage. This is all because this specific characteristic of local pollutants whose effects are concentrated in time and space. So where emissions originate matters for local air pollution, like greenhouse gases, whose effects can spill over time and space. Let me skip the literature, and here is the policy background. So in 2020, Korea introduced this cap and trade program in these 4 colored areas. They are basically polluted and populated districts in South Korea. When you look into social cost of emissions before the policy in 2018, this is exactly the regions where the policy was implemented. And this is a bit of more details on the policy. The goal was to reduce these local air pollutions in populated and polluted districts. These emissions can come from either fossil fuel use, just like the carbon content of fossil fuels, or they can also come from production process. Because, for example, if you produce paper-related products, for example, you end up emitting a lot of dust in the air. That's why this is another source. And these pollutants are known to damage the health, infrastructure, and environments through smoke, acid rain, and so on. The policy has size and space variation by targeting large polluting establishments within such districts. Here in this project, I'm just gonna focus on manufacturing and power plants. Yes.
So can I ask what's the reason, like why some districts are included in the cap and trade program and some are not, and should we worry about self-selection here?
Right. The reason why this policy was localized is because the government was not able to implement this policy nationwide because they have some limited capacity, but they had some kind of priority by targeting where people live most and where it was highly polluted, because local air pollution, the effect of local air pollution is highly localized. And since this is cap and trade program, it's a kind of market-based mechanism where caps are set to pre-regulation levels and decline linearly over time. And within caps, permits are fully allocated to regulated establishments. And trading of permits is allowed within pollution market, which is defined by pollutants times district combination.
So the cap is specific to the firm?
The caps are defined at this pollution market level, and then establishments in this market basically get free allocation within these caps.
So do they give some area more for allowances or not?
Yeah, there are some regional differences in setting the caps.
I guess what I'm asking, how do they move from the cap in a particular district to the firm?
How they move from caps to
the allowances are charged by firms, right?
Right. So when they say caps in the pre-policy emission levels, these are basically the total emissions of regulated establishments before the policy was implemented. And that's how they fully allocated in the first place. And these caps and also these permits linearly decrease over time.
I see. So they each firm gets a set of free allowances.
Yes. And this is the data I'm using. All text code links, annual data from 2016 to 2023. I have some policy documents that shows regulated establishments and their pollutants, emissions, emission factors. I also observe inputs such as fuel use, emission control measure use, and sales. To summarize, this data covers net, all the universe, in the sense that it covers all the manufacturing power plants in Korea. And this gives me the advantage of finding a better counterfactual or the control, also to study the spillover. And also, since I have a better measure of local air pollution, this is a lot better than just using fossil fuel use, which is commonly used for greenhouse gas emissions using fuel emission factors. The only caveat I have in this data set is I only observe emissions at this district times industry levels. But for quantification, I'm going to use both flat level data moments as well as this aggregate moments to discipline the model and estimate parameters.
Just ask on the data there, sorry, two the related questions. One is, do you see linkages? So either ownership or supply chain linkages or something?
Oh, I do not see linkages at the from transaction level.
But you know if they are substituting production across firms within the same.
I have a piece of evidence on spatial leakage. I will show you in.
Okay, and the
slides.
second is, should we think of in leakage terms offshoring or kind of transboundary leakage is important here?
Yes, it will be, but in terms of the total magnitude, it will not be overwhelming, but there will be some when you think about leakage across regulated and unregulated industries.
I don't mean within Korea. I mean
outside. That's a pretty good question. In this data, I do not have good measure of exports and imports, but I think that will be interesting thing to study. And I estimate the relative policy facts using difference in differences. I also do the same exercise at the plot level, but for today, I'm going to just show you district times industry level specifications. First, I compare the trends in emissions between regulated and unregulated district industry pairs. This is a standard difference in differences with some fixed effects and so on. I also compare trends in emissions between unregulated pairs. And here I have closeness measure, which is the log distance to nearest regulated district centroid with a minus sign front. So this measures how close these pairs are to regulated districts. So this is kind of measure of exposure to leakage. There are some identifying assumptions which are standard in differences. Here I argue that the policy was hard to anticipate because it was based on past emissions, which are hard to manipulate when the policy was announced. And the policy itself was suddenly rolled out. For power trend, I do use matching and fixed effects to balance the treated and controlled. However, still there will be some spillovers to control and, in other words, unregulated plants. For that, I'm going to use a quantification and use a model later. This is the only empirical evidence that I will show for the sake of time. This is manufacturing sector emissions, log emissions for regulated pollutants. As you can see, once the policy was implemented here, they show some significant decrease, which is around 50%. However, this includes both abatement and leakage. And actually, leakage was there because this is from the second specification where I have this closeness measure. And as you can see, for pairs that are closer to regulated districts, they have higher emissions after the policy was implemented. And this magnitude is around 1, which is what you find in trade elasticity, which is basically measure how exports or imports move in response to tariffs.
Sorry, can I ask you one thing? Normally in this literature on environmental quality, etc., they separate these effects into like technique, scale, composition effects, right? And I guess abatement here will be a technique effect and leakage the scale. Do you do a careful the composition on this, separating these two, or?
You mean the composition of these three facts using, okay, yeah, I also do that and it's in the appendix. And I find some consistent evidence as I have in these differences.
Okay.
I was wondering, I feel like another kind of leakage some papers that documented is like water. Like when I think there's like this Clean Air Act papers that like document that firms substitute into more water polluting technologies after there's tightening regulations on air. I wonder if you like have any data would also speak to this.
Which one?
Sorry, so water pollution.
Water pollution. I see. That's interesting. But this policy was specific to this local air pollution. But
Yeah, so the other leakage is they could leak into becoming more water polluting.
yeah, that sounds interesting. I will. Yeah, I don't know whether I have good measure of water pollution, but I think that sounds interesting. Just to taking stock, these findings indicate that emissions fall mostly in manufacturing, but not so much in power. That's because manufacturing firms started using more electricity, and somehow they cancel out the policy effect on power generation sectors. And there are some other disabatement leakage channels. However, exactly because of this leakage, structural approach is required to better interpret these reduced measures, because it will be biased, because there is basically no clean control group, because they either get emissions from production because of this policy. Also, I'm going to use a model to conduct some counterfactual policy experiments. Just to briefly summarize the model is a spatial generic linear model of manufacturing and power plants. I'm building on manufacturing and emissions model of Shapiro and Worker 2018, and also a model of manufacturing and power generation of our collective March 2024 paper. I combine these two, adding these channels. I add spatial and fuel substitution channels with rho and lambda, and emission control measure used with this alpha LSE. And I also allow leakage within and across sectors and districts, which are basically generic equilibrium spillovers. The model will be static environments with many sectors and districts, and how they behave are exactly the schematics that I showed you before. So manufacturing and power plants produce and sell across districts, and they either emit or abate leak once they get regulated. Here, I only allow manufacturing firms to have multiple plants under the same firm ownership. This is because power plants are under dispatch with a specific mechanism. It's kind of harder for them to relocate production within the same firm ownership. I do not allow entry and exit just to capture the short-run effects, because I only look into 8 years before and after the policy. Here, government will only impose pollution taxes that vary by pollutant size and district, just as in the policy. Households will derive utility from consumption and disability from emissions. I will jump to the calibration and estimation. In total, there will be 250 districts, 10 manufacturing sectors, and 4 fuel types, and 4 power generation fuel types. I'm going to calibrate some of these social costs and other parameters, but I will estimate the key parameters that I explained before. I'm going to use a control function approach to pre-regulation moments to estimate this rho and lambda, which are vector and fuel substitution elasticities. I'm going to match this difference in moments and pre-regulation moments to structurally estimate the policy-related parameters, whether how it was intense, and also the emission control measure elasticities. So this is the first quantification exercise that I would do with this model. So this is district times manufacturing industry, and this is local emissions, and this ADT from the difference in differences. I use a model to match this moment, which is pretty close. It's around minus 0.5. And then I can use a model to explain what happened to regulated plants inside. Then I can see that pure emissions reduction without leakage is closer to cap changes in real data. And I can also see that the difference here is right here, which is basically from unregulated plants. So measured reduction is overestimated by this box through leakages across regulated and unregulated districts. So this is consistent with the geographic leakage evidence that I showed before.
So this would argue you should make the market nationwide, right?
I'm sorry.
You should do the market throughout Korea, not just in certain districts.
Actually, that's a pretty nice question because I will answer that right here, where I study welfare and distribution consequences across space. I'm gonna say that actually, despite this leakage, this policy was welfare improving, because when you think about the from the social planner's perspective, leakage can be good for local air pollution because it will be headed to places where people are where the population density is low and also pollution is low. So the social damage of these emissions will be low. So leakage can be beneficial. Also, the people in this unregulated district might suffer. Yeah. So that's the takeaway from this exercise.
It's the intuition is I want to have firms with higher pollution to move to the place where there's less population. And that's why national policy won't be a better policy. Is that the intuition?
Yes, to some degree. I mean, that's not the only way that emissions can be decreased, because they can also abate through like filters and scrubbers. But there can be still some leakages. But what I want to say is that unlike greenhouse gas emissions and their regulations, leakage can be good here because their effects are concentrated in such districts. Yeah. So just to show you some map results here. These colored areas were where the policy was implemented, and they are highly correlated with decrease in social costs, but not so much in consumption because of this trade and everything, everyone suffers in response to this kind of pollution taxes. But the social cost of emissions decrease a lot further in regulated districts. So just to summarize, I want to say that when you think about local air pollution, targeting highly polluted regions and densely populated regions and large polluters within can be welfare improving relative to global policies and others. Yeah.
Sorry, maybe I missed this. Did you have results on sort of technology adoption or changes in abatement costs? Because I would imagine like one thing that was going against this not going national is that if it goes national, assuming there are different margins through which you adapt to the policy, then you might be more incentivized to adopt abatements or technology adoption when you cannot just move. Whereas if it's regional, you can move, and so you wouldn't install new stuff, you would just move. So in some sense, maybe if you account for that, maybe it could be better to do nationally.
Oh, I see. Yeah, that's possible, but on the flip side, we need to consider how costly it is to decrease emissions through clean technology.
Yeah.
So in terms of welfare, I have to see the numbers. Yeah,
Okay.
but that's. Yeah, go ahead.
Just a curiosity, you're not dealing with eventually dispersion of pollution across space, across these units?
Right, I'm not doing that because these are local air pollutions, and I assume that they have all the effects within these districts.
Okay, but is this eventually something that you think it will be worth, out of curiosity, investigating, right? I think that eventually wind can disperse a lot of pollution across space, and eventually moving where economic activity is going to be generating pollution is going to potentially affect who is going to be affected downwind, right? Do you think this could be relevant in your?
I totally agree with you. I think that can be an interesting extension when I do welfare analysis in the end.